Hey Codebreakers, welcome to Science Week 2025. This year's theme is Decoding the Universe, exploring the unknown with nature's hidden language. What does that mean? Well, imagine the world is speaking its own secret language through colour, sound, patterns, and movement. From animal behaviour to star signals, nature is full of messages just waiting to be decoded. So sharpen your senses and get ready to crack the code of nature's hidden language. Let's start with a classic, camouflage. Some animals blend perfectly into their surroundings to hide from predators or sneak up on prey. A green tree frog vanishes among leaves, a stick insect disappears into twigs. Their colours and shapes help them survive by being invisible. But animals don't just hide. Mimicry helps animals and plants survive by looking like something else. In Brazil, some butterflies copy the patterns of bad tasting ones, so birds avoid them. Dangerous insects like sand wasps and yellow jackets look alike. Their shared yellow and black stripes warn animals to stay away. Some animals use mimicry to catch food. The alligator snapping turtle's tongue looks like a worm. When fish come close, it snaps them up. Even plants use mimicry. Passion flowers grow bumps that look like butterfly eggs, stopping real butterflies from laying eggs on them. This protects the plant from hungry caterpillars. They also send messages. Stay away, shown with bright warning colours or defensive displays. I'm here to impress, like the dances of birds of paradise or the claw waves of fiddler crabs. Follow me to food, like the waggle dance of bees, which gives directions using angles and vibrations. When we decode these clues, colour, shape, movement, we become scientists of animal communication. Nature has plenty to say if we know how to read the signals. Now let's talk about a hidden pattern called the Fibonacci sequence. It's not magic, it's maths. The number pattern goes like this: 1, 1, 2, 3, 5, 8, 13. Each number is the sum of the two before it. 0 plus 1 is 1, 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8, 5 plus 8 is 13, and that code keeps on going. The sequence appears in spiral shells, sunflower seeds, pine cones, and galaxies. It's nature's way of growing things efficiently, arranging petals to catch the most light, or seeds to pack in the most space. When we spot Fibonacci in nature, we're decoding how the universe organises beauty. The sequence is named after Leonardo of Pisa, nicknamed Fibonacci, a medieval Italian mathematician who introduced this pattern to Europe in the 13th century. Although this pattern existed in nature long before, Fibonacci's work helped connect maths and the natural world. Now for something a little tricky: optical illusions. Your eyes collect information, but your brain has to figure out what it means. Sometimes it makes quick decisions and gets it wrong. Illusions reveal how our brain processes light, contrast, depth, and movement. They show us how the brain fills in blanks and chooses what to focus on. Is it spinning? Is it growing? Is it a duck or a rabbit? When we explore optical illusions, we learn how the brain works behind the scenes, decoding the world, but also sometimes getting it hilariously wrong. Not all messages come with pictures or sounds. Some arrive as rumbles beneath our feet. Deep underground, the earth is always moving. These movements send out seismic waves, vibrations that travel through rock and soil. Scientists use tools called seismographs to detect and record them. Every jagged line on a seismograph tells a story: how strong the movement was, where it happened, and what caused it. By decoding these patterns, scientists can understand earthquakes, study volcanoes, and even peek into Earth's deep layers. Now, not all codes come from Earth. In deep space, planets like Saturn send out signals we can't see, but we can listen to them. Scientists used radio telescopes to detect radio waves coming from Saturn. These aren't sounds in the usual sense, they're electromagnetic signals turned into sound so we can hear them. So, what are we hearing? Possibly electrical storms in Saturn's atmosphere, magnetic field activity, charged particles from the solar wind. These signals help scientists decode space weather. Aboriginal and Torres Strait Islanders have been decoding the universe for over 60,000 years, reading the stars, seasons, plants, animals, and the land to survive and thrive. This deep knowledge has been passed down through stories, song, dance, and practice, forming one of the world's oldest and continuous systems of science. The Noongar people of southwest WA recognise 6 seasons based on environmental changes. These seasonal shifts are signalled by plants flowering, animal behaviour, rainfall, and temperature. This living calendar helps guide movement, hunting, and land care. Barak is hot and dry. Traditionally, this is the time for controlled burning. To regenerate the bush, the sea breeze returns in the afternoon and reptiles are active. Bunuroo is the hottest time of year with very little rainfall. Freshwater sources dry up, so people move closer to the coast to fish and gather shellfish. White flowers like paperbark start to bloom. Jeren, the weather becomes cooler and more dewy. Flying ants appear. Banksias begin to flower, and it's time to prepare for the colder months. Makaroo, which is the coldest and wettest season, water levels rise and animals seek shelter. Hunting focuses on kangaroos and emus, and red flowers like the bottle brush bloom. Jilba, the land stirs with new life. It's a season of change, with wild weather, newborn animals, and yellow flowering wattles marking the transition to warmth. Camberang, warming weather, longer days, wildflowers explode in colour, reptiles return, and the land buzzes with insect life. It's time for harvest. Well, we've explored nature's cleverest codes, from animal signals and flower spirals to earthquakes, illusions, Saturn sounds, and deep First Nations knowledge. Every puzzle is a chance to think like a scientist, to observe, question, and decode. Now it's your turn. Log into Moodle and choose an activity that lets you crack one of these natural codes for yourself.